Good afternoon, children. I have already discussed preparation of amines by various methods. Now let me discuss physical and chemical properties of amines because there are many conceptual questions which are based on the physical properties. The first physical property is known by the name of a physical state. Physical state. The first three members of amines are gases, having a smell like ammonia. The next three members are liquid. These are having fishy odor. The rest of the members are solid and these are having unpleasant odor. All the aromatic amines are toxic in nature. Toxic in nature. Aromatic amines are toxic in nature. These amines are initially colorless, but due to the atmospheric oxidation, they become colored. We are having aniline in the lab, which has become brown in color. Otherwise, initially when we have purchased, this was colorless. The next very important property is the boiling point. Amines are polar in nature. They are having higher boiling point than the hydrocarbons of the same molecular masses because they can make hydrogen bonding and because of they exist in the form of a associated molecules. The boiling point of amines is higher, it is greater. Boiling point of amines is greater than that of a boiling point of hydrocarbon, which are of a same molecular mass. But if I discuss the boiling point or I compare the boiling point of amines with alcohols and carboxylic acid, the carboxylic acids are having maximum boiling point, then is the boiling point of alcohol, then amines. All the three are polar in nature, but carboxylic acid is having two oxygens, alcohol is having one oxygen, and there is no oxygen present in amines. The electronegativity of oxygen is more than that of a nitrogen. So, because of the presence of electronegative oxygen, the boiling point of carboxylic acid is more. All the three are able to make hydrogen bonding with the exception of tertiary amine where there is no hydrogen. So tertiary amines are not able to make hydrogen bonding. But in carboxylic acids, there are two electronegative oxygen, whereas in alcohols, there is a one electronegative oxygen. So the boiling point of carboxylic acid is greater than that of a alcohols, and the boiling point of alcohols is greater than that of a amines due to the formation of a extensive hydrogen bonding. The third physical property is solubility. The lower members of amines are soluble in water because they can make hydrogen bonding. All the aromatic amines are insoluble in water. In the aliphatic amines, as there is an increase in the only hydrocarbon part, which is hydrophobic in nature, the solubility decreases because then they are not capable of making hydrogen bond. So there is a decrease in the solubility takes place. Otherwise, the lower members of amines are soluble in nature. Now, the next one are the chemical properties which are very much important and you have to understand these because if you will not understand, it will not be possible for you to do the questions, because the maximum number of questions are being asked from the chemical properties. The first most important chemical property is of amine is that amines are basic in nature. There are three reasons for the basicity of amines. First, nitrogen is having lone pair of electron. Lone pair of electron. Second, there is a presence of acidic hydrogens. Acidic hydrogen. Third, there is a nitrogen is electronegative. Electronegative. Now the question becomes, why amines are basic in nature? The amines are basic in nature because of the three reasons. First, nitrogen is having lone pair of electron. Second, there is a presence of acidic hydrogen. And third, the nitrogen atom is electronegative in nature. So that is why amines are basic in nature. Now, if we compare the basicity of primary, secondary and tertiary amines, because all the three amines are having lone pair of electrons, but because of the difference in the number of acidic hydrogens, their chemical properties changes, their basic strength changes, and because their sum of the chemical reaction are different from each other. So let me discuss first the basic character of amines. If amines are basic, it is but natural they will react with acid. It is not necessary that I have to take here primary amine. I can take secondary amine, I can take tertiary amines. The amines will react with acid and they will form salt when they will react with acid. R NH3 positive, X negative, because the proton has taken lone pair of electron from nitrogen, so obviously there will be a positive charge on the nitrogen. Similarly, if we take aromatic amines, suppose there is aniline and the reaction is done with acid, there will be again same type of reaction. There will be NH3 positive, X negative. So that means all the amines, when they will react with acid, they form salt. This indicates that amines are basic in nature. Second is the reaction of amines with water. If the amines react with water, they give hydroxyl ion, and any substance which give hydroxyl ion is always basic in nature. Let me write the reaction of amine with water. R NH2 plus water. There will be formation of R NH3 positive and OH negative. If it is aniline and the reaction is done with water, there will be formation of anilinium ion, NH3 positive, with the release of hydroxyl ion. Because there is a release of hydroxyl ion is taking place, which tells that the amines are basic in nature. Because of the formation of hydroxyl ion, this indicates that amines are basic in nature. Now, if the reaction of amine is done with base, then there will be formation of original amine with the release of only NaX and that of a water. If the reaction of amines is done with base, like any strong base, R NH3 positive, the reaction is done with a base, there will be formation of primary amine or secondary or tertiary amine with the release of water. So in this manner, we can obtain original amine by the reaction of any ammonium cation with that of a base. There will be formation of original amine will be taking place. Now, some experiments were done to determine the basic strength of amines. In these experiments, the basic strength of amines were calculated by measuring their dissociation constant. The dissociation constant of base is written by Kb. You all know. Now, if the reaction of any ion or ammonium cation is done with water R NH3 positive and the reaction is done with water, there will be formation of base RNH2 and with that of a release of hydroxyl ion. If the reaction of any ammonium cation is done with that of a water, there will be formation of RNH3 positive and that of a hydroxyl ion. Now, due to the presence of hydroxyl ion, we can very easily say that amines are basic in nature. Now, because there is a sign of equilibrium, if I write K equilibrium, it will be equal to concentration of R NH2 OH negative R NH3 positive and that of a concentration of water. If I mix this concentration of water with K equilibrium into concentration of water will be equal to Kb. The concentration of water does not make any difference on the reaction. So that is why it can be very easily mixed with K equilibrium. It will be written as Kb is equal to R NH2 OH negative divided by R NH3 positive. Now, greater the value of Kb, more is the basic strength. Greater the value of Kb, more will be the basic strength. Now, this Kb value, because it comes in the tens की power minus 7, tens की power minus values, so it is being converted in the form of pkb. It is converted in the form of pkb, which is a log value. Pkb is equal to minus log kb. Now it is a reverse. Smaller the value of pkb, the more is the basic strength. Greater the value of kb, the more will be the basic strength. Smaller the value of pkb, the greater will be the basic strength. Now, I will compare the basic strength of ammonia with amines. Now, I will compare different basic strength. First, I will compare basic strength of ammonia with alkyl amine. Alkyl amine is more basic than ammonia. Alkyl amine is more basic than ammonia. Why it is more basic? There is a lone pair of electron on this amine and there is a lone pair of electron on ammonia. Both of them can give lone pair of electrons, but in the case of alkyl amines, there is a alkyl group attached with nitrogen. Alkyl group is a electron donating group. It will increase electron density on nitrogen. So this will be easier for alkyl amine to give electrons. Now, this will show plus I inductive effect. This will show plus I inductive effect. No such type of effect that will be found in that of an ammonia. In ammonia, there are only 3 hydrogens. No such type of plus I effect is there. So that is why there will be the ammonia is less basic than those of alkyl amines. Now, I will compare the basic strength of primary, secondary and tertiary amines. There are 3 theories behind it to compare the basic strength of primary, secondary and tertiary amines. There are 3 theories behind it. One of the theory you can use any. One of the theory that is only known as the presence of alkyl group. The presence of alkyl group due to plus I effect. Due to plus I effect. Now, if we see the plus I effect that depends upon the alkyl group. Greater the number of alkyl groups, more is the plus I effect. So, if we only say the tertiary amines is having more number of alkyl groups, so according to the theory, it will have maximum plus I effect. Now, if we see the order of basicity, it is tertiary, secondary and primary. But this order is only found in gaseous phase. This order is only found in gaseous phase. If we see the order in water, if the amines are dissolved in water, due to the dissolution of amines in water, there will be 2 effects. One of them will be known by the name of solvation effect and the other one will known by the name of steric factor. The basicity will depend upon the steric factor. The basicity will depend upon the solvation factor. Do you know what is the meaning of solvation? Solvation means when these amines are dissolved in water, when these amines are dissolved in liquid. Now, the basic character in acidic phase I have told you, this is tertiary, secondary and primary. Now, if we see the order in liquid phase, the order will be, it will be secondary amine R2 NH, then it is R3 N and then it is RNH2. This order is found when the alkyl group is C2H5. Then it will be C2H5 whole thrice N, then it will be C2H5NH2. And if the alkyl group is CH3, then this order will be C2CH3 whole twice NH, then CH3NH2, then it will be CH3 whole thrice N. Now I will tell you reason why the order of basic strength like this way. In the case of tertiary amine, if we look at the order, in the case of, there is a first one is that of a steric factor. Now, there are three alkyl groups. I have told you that there are three theories. The first theory is the order of basicity due to the alkyl group, that is in gaseous phase. Tertiary most basic, then secondary, then primary. Then in the liquid phase, when amines are dissolved, there are two more theories. One of them is steric factor and second one is solvation. In the case of steric factor, if there are three alkyl groups in the tertiary amines, that will cause crowding and there will be less availability of lone pair of electron. So the basicity for the tertiary amine that will decrease. Suppose you go in a ground and you have to take something. If that ground is very much crowdy, it will be difficult for you to get the things. And if it is less crowdy, you will be able to take the thing. The similar things happen in the case of tertiary amine. The less availability of lone pair of electron is there when there are more number of alkyl groups. The nitrogen is having lone pair of electron, but it becomes difficult to approach for any acid to react with it. So there will be overcrowding. So due to the steric factor, there will be decrease in the basicity. The second effect is solvation. The solvation depends upon the stability of ammonium cation. Whenever any amine is dissolved in water, it reacts with water to make hydrogen bonding. And in this process, there is a release of energy which is called only hydration energy. Greater the amount of energy release, more is the stabilization of ammonium cation, more is the stabilization of cation formed by amines, and the more will be the acidic, more will be the basic strength. The basic strength depend upon the stabilization of cation. So in this case, when the solvation will be taking place, there will be release in the hydration energy. The maximum amount of hydration energy that will be released in the case of primary amine, and in the case of primary amine, the only cation formed that will be very much stable. Then it will be the hydration energy of secondary amine, and then it will be the hydration energy of tertiary amine. Now, because of this solvation effect, the primary amine should be the most basic. But due to the combined effect of inductive effect and that of a solvation and steric factor, the secondary amines are more basic, and other than it will be depending upon the alkyl group. The greater the alkyl group, the order of basicity that will remain same. Secondary will be the most basic, but here there will be change in the order. If the group is ethyl, then there will be, after that it will be tertiary, then primary. If group is alkyl, it is methyl. Methyl group does not cause any steric hindrance. So because of this, the secondary will be most basic, then primary, and then it will be tertiary. You go through book, read it. This is very important. If there is any query, let me know. Otherwise, I would like to repeat some part of it in the Zoom class so that you are able to understand.